Hello and welcome to a tutorial on how to use the Epson Robot Connectivity plugin to connect visual components with an Epson Virtual Robot Controller.
When following any tutorial, check the lesson on the Visual Components Academy, and if the Download Files option appears, you can download the example files.
The Epson Robot Connectivity plugin requires that we have the Epson RC Plus 8 software installed on the same computer as our Visual Components software. Information on where to download any additional software components will be included in the video description. And before we start, later in this lesson, we are going to use an add-on available from the Visual Components forum. Installing the add-on requires restarting the application, so we could install the add-on now before we start. To download the add-on, in the Help tab, search for Post-Processor Download and open the forum result or use the link in the video description. Then exit the application and copy the Robot Post-Processor Download into the Python 2 folder in our My Commands folder and extract it there. Then start the application and the add-on should appear in the Program tab. This plugin offers direct integration with the Epson Virtual Robot Controller, so we don't need to have the Epson RC Plus software running separately, as Visual Components will manage the Virtual Robot Controller directly. We have built a layout inside Visual Components, and here we want to control this Epson robot with an Epson Virtual Robot Controller. First, we will navigate to the Connectivity tab, and on the left-hand side, choose the Epson Robot Connectivity plugin. And then we can either right-click to add a server, or click Add Server from the toolbar above. This will open the Edit Connection window on the right-hand side. Here we can select the connection type. We can choose either a virtual robot controller or a real robot controller. For this tutorial, we are using a virtual robot controller. So what we can do here is first select a project path for our RC Plus project. This is not mandatory. Typically, the RC Plus projects are stored in the Epson RC Plus folder under Projects. And we have a test project file here that we will open. The project has an associated virtual controller, C4B sample, and we will use this for the tutorial. We can also use scan controllers to directly choose a virtual controller, and it does not necessarily need to have a project associated with it. We can also test the connection, but this will take some time, as the virtual robot controller needs to start. So we will directly click on Apply, and then go on the left-hand side to click on the Connect Disconnect to establish connection with the virtual robot controller. Please note that this will take some time as the virtual robot controller needs to start. Now that the connection with the Epson Virtual Robot Controller has been established, this icon here has turned green and we have a live connection. On the right-hand side, we can see some of the server properties. So we have the ability to start, stop, and reset the virtual robot controller together with the simulation. Additionally, under Advanced, we have buttons to open additional panels. So for the 3D scene, we can view the 3D view of the robot in the Virtual Robot Controller project. From the Task Manager view, we can see the current Task Manager list for this robot project. The Robot Manager view will let us control the robot, turn the motors on and off, set the power, and then jog the robot individually. Finally, the Program Mode view will open the project window in Epson RC Plus, where we can then manage our project. To get started, we will move from the Connectivity tab to the Program tab, where we have created a simple robot program. And now we would like to translate this robot program from Visual Components to the Epson RC Plus project. For this, we will use the post-process add-on we installed earlier, which will detect that we have an Epson robot, and we will add the project. Let's name it tutorial_1 and click Save. And it was saved directly to our project folder. It created one file for the program and one file for the points. Then we will disable the robot executor in Visual Components, so we go to Component Properties and Executor, and we will set the Is Enabled to False. So now when we start the simulation, the robot won't be performing any motions while we have the connectivity active. Now on the Epson RC Plus side, we can again open the program mode. For the program file, we will choose Add Program File, Existing File, and navigate to the Project folder. Select tutorial_1 and click Open. We will delete this My Program and do the same for the point file. So we will choose an existing file, tutorial_1 points, and click Open and delete the old points file. Now we can open the 3D scene view to get a view of the robot. Then we can start pairing the variables between the Visual Components robot and the Epson RC Plus robot. What we need is to pair the variables from the virtual robot controller to Visual Components. So we will select Server to Simulation. Right-click, select Add Variables, and over here, choose the Robot 1 and multi-select joints 1 to 4 on the virtual robot controller side. And then on the Visual Component side, type value in uppercase for the variable name and select joint 1 value, joint 2, 3, and 4, and click Pair Selected so that these values are paired. Additionally, we will pair the robot signals so that these values are paired. So we will choose Show Signal Maps, expand robot outputs, and in the program we have used the output 15. So we can also use the standard output 15 on the virtual robot controller and click Pair Selected. And now we have paired joints 1 to 4 and output 15 from the virtual robot controller to Visual Components. Next, we are ready to start the co-simulation. So we click play in Visual Components, and the robot will get its movement from the virtual robot controller. We will see how the robot in Visual Components is accurately moving the same way as it's moving in this RC Plus window. Additionally, we could stop the program and then manually jog the robot. So the Robot Manager window can move the robot joint 1. And we will see that the robot in Visual Components is also moving. We can also monitor the connected variables. And we could, for example, force their values and then write the values if needed for testing use cases. And this concludes the lesson. Thank you for watching.